So in this video we are going to learn about decay of current in an inductor. The previous video you have seen growth of current in inductor. So we have a charged inductor means the inductor is holding energy. So this inductor is holding energy and we are connecting a resistor R. Through this resistor, this inductor is getting discharged. So this is L. Now the decay of current in an inductor is so this is so on the y-axis we have current I and the x-axis time t. So initially the inductor current was maximum, then it started decreasing and it reaches 0 at infinity. Now the time period is there. We have time period L upon R is equal to tau. This L upon R is a time period. 1 time period, 2 time period, and then 3 time period, 4 time period, 4 times L upon R. Next 5 time periods L upon R. This L upon R we can write it as tau also. L upon R equals tau. So at one time period it is an exponential decay. The current in an inductor decaying exponentially. In one time period the current becomes I0 is the maximum current. Now what was the maximum current that can be provided by the inductor is the I0. So at one time period, that is 1 tau, the current decays to 0.3 x 36.8% of the maximum current value I0. Now this is given by an equation. What is the equation? This see the decay of current is given by an equation. What is that equation? That is I equals, this I is varying with time, I0 maximum current multiplied by e to the power minus t upon tau. This tau we can replace by L upon R. Now we have, okay, with the time, okay, I will write in the next here, I'll write the time period. What happens? One time period, see we have time periods, that is 1 tau, 2 tau, 3 tau. Let me write it a little bit bigger. 1 time period, 2 time period, then 3 time period, 3 tau, 4 tau and 5 tau. Now what happens? With 1 time period, in the circuit current reduces to 0.368 times of the maximum current. Maximum current, what is the maximum current? I naught. With the 2 time tau, this reduces to 13.5% of the maximum current. And 3 time period, it becomes 0.05 times the I naught. With 4 time period, it becomes 1.8%, that is 0.018 times of I naught. And with 5 time period, what it becomes? It is 0.007 times I naught. So after 5 time period, here the current is almost 0. We can say I equal to 0 after 5 time periods. So after 5 time periods, inductor is completely discharged. The energy is decayed completely. For all practical applications, we can consider after 5 time period, the energy has completely gone, dissipated through this resistor. Now what is one more thing we have to do? We know what was the thing we know? We know what was the equation for representing that curve. What curve? We got the decay of, this was I. We got a curve like this, exponential decaying curve. This was time. And this curve is drawn using the equation I of t also we can write it, because with respect to time, I naught maximum current multiplied by e to the power minus t upon tau. Now let's derive this equation. With that derivation, we can complete this small topic, a small and important topic, decay of current in an inductor. Okay, now we have our circuit, which is simple. So here the current, let us assume that current is flowing in this direction. Current I is flowing in this direction. So this end is going to be positive of the inductor. This is also positive, so current flows here. This is negative. We are going to apply KVL. This is negative. Now let's apply KVL in the anti-clockwise direction. I am moving anti-clockwise direction to write the KVL. Now let's start from here. From here I am starting, from the inductor. It's supposed to be, now let me write, if we simply use the KVL, it is plus L d upon dt, that is the voltage drop across the inductor, minus IR equal to 0. Now you tell me whether it is right or wrong. If it is a resistor, if there instead of L, if it was a resistor, then it is correct. And also, if it was charging of inductor, it was correct. Or growth of current in an inductor, it was correct. But here what is happening? Our d upon dt quantity is decreasing. So we have to make this as negative. Okay. So it has to be negative L di upon dt, because di upon dt is decreasing. It's not an increasing quantity. Now we can simply simplify this equation and get the decay of current equation of inductor. Now we have to rearrange. So minus L di by dt equals I multiplied by R. This minus and L will take to the right side. So that is di upon dt equals minus of R upon L I. Now same di upon I, we will bring it to the left side, dt we will take it to the right side. So minus r upon L t. Now from this equation, if you want I, what we have to do? We have to integrate. And what is going to be our limit? Current will be from I0 to I. I0 to I. And time from 0 to t. All right, on the left side. Now if you integrate, we will get log of, let me write it properly, t dt. Log of I, what is the limit? I0 to I equals minus r upon L t. T also limit 0 to t. So there we are going to get t. When you integrate, we will get t only. Now on the left side, if you write, if you use the limit and logarithmic proper limit, let's write it as limit only first. So it comes to log of I minus log of I0 equals minus r upon L t. R upon L multiplied by t. Now if we apply log of I upon I0. Is that right? I am applying the log. Log a minus b equal to log of a upon b. So here minus r upon LT. Now let's write it here. Okay. Now see, if to remove this log, this is natural logarithm. We will take the exponential on both sides. Then what we will get? I upon I0 equal to minus r upon EL, not minus, exponential we had to write. Exponential of minus r upon L into t. Now we got this equation. Now how do you simplify and write it? I want to write it in the same page itself. How? So this can be written as I equals I0 multiplied by what is there in the e to the power minus r upon L multiplied by t. This is the equation we got. We can further simplify this in terms of tau. We can write it as, I'll write it here itself. How can we write it? That is tau equal to what? L upon r. So this r upon L I have, minus r upon L I have in the e to the power. So what I will do, minus I'll put it there. I'll write 1 upon L by r. I can write it. So this is same as minus r upon L. Then I'll rewrite this equation using that tau. That is I equal to I0 multiplied by e to the power minus t upon tau. This is the simplified equation. This is the equation for the decay of current in an inductor. So I hope these videos are useful to you. If you like the video, please share with your friends and don't forget to hit the like button.